So today we are going to talking about the case study problem 2, CTA electric service. So basically, the question is talking about the background. Let me talking about the informations. I'm Alex. So CTA electric service is an electric company serving several sites in the CTA regions. It considering and thinking on replacing some of the equipment such as the PCB transformers for the generating substations and try to considering whether would it be replaced or not. So for the case, they got two scenarios. The first one, which is talking about if they try to replace the PCB transformers, they may be only handling the cost of transformers. And the second scenario, which is if the company decides to keep it of the existing PCB transformers, then they will estimate some of the 50-50 chances of consequence likelihood happens during the incidents, maybe related to the damage rather than having a fire or not. And then speaking of which, my groupmate will talk about the decision tree diagrams.
Okay, thank you, Alice. I'm Nettie. Now I'm talking about a multiple decision tree. First, we can see that we have the two situations. One is replace the BCB and one is keep the BCB. First, I will talk about replace BCB. And this will have just a one solution with the incident. And this P is 0. And the other is the keep the PCB. We have the two situations. Right? One is the high likelihood and one is the low likelihood. And on the high likelihood, we will have two situations too, which one is the fire and one the no fire. And on the fire, we have the keep going and the other one is the bad fire and one is the minor fire. And on the bad fire, we have the 19 million budget, and on the medium fire, we have the 8 million budget. And the possibility on the backfire is 0.2 and the minifire is 0.8. And on the fire on the high level will be 0.004 and no fire is 0.996. And on the no likelihood, on the no fire point, the possibility will be 0.999 and on the fire is 0.001. And on this backfire situation on the low likelihood, the spectral still is 90 million and the possibility is 0.2. And on the minor fire is the budget still is 9 million and the possibility is 0.8. And go back to the keep CBB process, and the high likelihood possibility is 0.5 and the low likelihood is 0.52. Okay, next our part is Jason.
Yeah, I'm Jason Ho. I will talk about the calculations that the total expected cost of replace the BCP transformer is 85,000. And for the situation in keep the PCB transformer, the expected cost of backfire is 90 million times 6.2. So we can get 80 million. And the expected cost of linear fire is 8 million times 0.8. So we can get 6.4 million. So we can get the expected cost of total fire, it is 24.4 million. The expected cost of high likelihood of an incident is 24.4 million times 0.004 plus 0 times 0.996, so we can get 97,600. Because the same cleanup cost for high and low likelihood of an incident, so the expected cost of low likelihood of an incident is 24.4 million. The expected cost of no likelihood of an incident is 24.4 million times 0.001 plus 0 times 0.999. So we can get 24,440. So you can calculate the total expected cost of keep the PCB transformer, which is the expected cost of high likelihood of an incident times the probability of high likelihood and plus expected cost of low likelihood of an incident times the probability of low likelihood. So we can get 61,000. So I pass to Jason now to talk about the result.
Yes, I'm Jason now. So, even though in the expected cost, we can see that keep the PCP transformer, the price will be much cheaper than the replace it. But as you can see from the graph, that actually if we keep the PCB transformer, actually they will have like a high chance that we need to pay the cost more. So in the conclusion, we think that replacing the PCB transformer is the recommended decision for the company's ESG. That means the environment, society, and the governance. Because actually, if the fire is happen, actually it will not only pay a lot of costs for the cleanup, but it's also a environmental and social responsibility because the TCP is a toxic material. So the container should, the transformers should be in a good status at all time. So this is the presentation that we made for the question number 2, and hope you enjoyed it.